All right, this video is picking up where the video notes, the preview notes, ended. So we'll start with example 4. And we're going to take a look at the equation 2 raised to the x power is equal to 2 raised to the 3 power. There should be an obvious solution here of x is equal to 3, and this is the only solution. So there's only one solution to this equation, and that's because 2 raised to any other power doesn't give you the same value as 2 raised to the 3 power. And that's because exponential expressions are 1-to-1. However, if I look at the next equation, there is an obvious solution of x equals 4. However, 1 to the 3rd power is equal to 1 to the 4th power because 1 raised to any power is 1. So there are an infinite number of solutions, or all real numbers are solutions to this equation. And that's because we have the boring base of 1. 1 raised to any power is 1, and so therefore when we consider exponential functions, we really won't work with a base of 1 because of that property. That brings us to the 1-to-1 property of exponential functions. If our base is not 1 and b raised to the x equals b raised to the y, then x is equal to y. This gives us a technique that we can use to solve exponential equations by expressing one side of the equation as a power of the same base and then using properties of exponents to simplify and then equating our exponents and solving. So let's take a look at example 5a. 2 raised to the x power is equal to 2 to the 16th power. So I'm going to bring down my 2 to the x, then I'm going to express 16 as a power of 2. And 2 raised to the 4th power is equal to 16. Now we can use our 1-to-1 property of exponents to set those exponents equal and say that x must be 4. All right, let's kick it up a notch. So now let's take a look in B at two sides of our equation that can both be expressed in base 2. 4 is 2 raised to the 2nd power, and 8 is 2 raised to the 3rd power. Now we can use properties of exponents. When we raise a power to a power, we multiply the exponents, so 2 times x plus 3 is 2x plus 6. And then same thing on the other side of the equation. 2 to the 3rd raised to the x power is 2 to the 3 times x power. Now that we have both sides as powers of 2, we can simply equate the exponents and solve. And so subtract 2x from both sides, and we get x is equal to 6. All right, let's take a look at another. In C, we have powers of 3, it looks like. 3 squared is 9. So we have 3 squared to the 2x minus 1, and 3 cubed is 27. So we have 3 cubed raised to the 4x plus 2. When we raise a power to a power, we multiply the exponents. 2 times 2x minus 1 is 4x minus 2. And 3 times 4x plus 2 is 12x plus 6. Don't forget to distribute. When we multiply times a binomial, we have to distribute that multiplication to both terms of the binomial. Now that both sides are both powers of 3, we can equate the exponents. Subtract off 4x, subtract off 6, and divide by 8 to get a solution of x is equal to -1. All right, let's try D. Here we have 4, which can be expressed as 2 squared. So we have 2 squared to the 2x, and then a half is a fractional value that can be expressed as 2 raised to the -1 power. So power to a power, we multiply our exponents. And on the right side, be careful to distribute that multiplication by -1 to both terms, which gives us -1 plus 2x. Now we can equate the two exponents and subtract 2 from both sides. Subtract 2x, and then divide by 2, and that gives us x is equal to -1/2. So speaking of fractional values, it is okay for an exponent to be a fraction. Let's remember how to express a square root as an exponential expression. The square root of 3 is the same as 3 to the 1/2 power. 9 is the same as 3 to the 2nd power. And now when we raise a power to a power, we multiply those exponents. So 2x minus 4 is the new exponent on the right. Now let's equate the exponents. And as always, if we have a fractional value, it might make it easier if we just clear fractions by multiplying all terms by 2. Don't forget to distribute that times 2 to all terms. And then adding 8 and dividing by 4, x is equal to 9/4. All right, let's try another. The cube root of 25, so that would be the cube root of 5 squared, and that winds up being, as an exponential expression, 5 raised to the 2/3 power. And on the right side, we have 5 raised to the -3 raised to the x minus 2 power. Multiply the exponents to simplify that power to a power, and equate the exponents now that we have both sides as a power of 5. We'll clear the fractions by multiplying through by 3. And don't forget to do that for all terms. So -3x times 3 is -9x. 6 times 3 is 18. Subtracting off 18, we get -16 is equal to -9x. And dividing through by -9, we get x is equal to 16/9. All right, there are a few for you to try. Pause the video and try E on your own. Okay, here's the solution to E. Now let's move to F. Try this one on your own and pause the video. Here's the solution to F, and I do want to point out that both sides can be expressed as powers of 2, and you will arrive at the same answer. It may give you a fraction that you then have to reduce, but we will get the same answer writing both sides as powers of 2. All right, let's move on to G. Try this one on your own and pause the video. Okay, here's the solution for G. And I do want to point out here that when you get to the point where we're dividing by 4, or rather dividing by -4 in this step right here, that we can, instead of dividing by 4, multiply both sides by -1/4, and it achieves the same result. That may give you an easier computation to do. All right, let's move on to compound interest. This is going to involve your calculator, so if you want to pause the video while you grab your calculator, do so now. And the compound interest formula is below here in blue. A equals P times 1 plus R divided by N raised to the N times T power, where N is the number of times per year interest is compounded. A is the dollar amount or value of the investment or loan. It can work the same in both situations. P is the initial dollar amount invested or borrowed. And R is the annual interest rate in decimal form, and T is the number of years. So we're going to compare some compounding situations. If I borrow $1,600, that's going to be our initial amount, so that will be the value of P, or principal, at a 9% interest rate. That's going to be our annual interest rate, as R is equal to 0.09 in decimal form. And we're going to compare the amount owed at the end of 5 years, that's our T value, for interest in compounded in each of the following ways, and then we're going to round our answers to the nearest cent. All right, so compounded annually. The thing we need to answer here is annually is how many times a year? That's once a year. So that would be like a simple interest, right? If we're compounding once per year. So I'm going to plug into our formula. Our formula is A equals P times 1 plus R divided by N raised to the N times T power. And P is the initial amount borrowed. and R is the interest rate, 0.09, divided by n, the number of times per year is 1, raised to the 1 times t, which is 5, power. From here, I'm going to let my calculator do all the computations for me. So don't do your calculation piecemeal. Do it all at once on your graphing calculator. And just enter it in exactly as you see it. So 1600, open parentheses, so that'll be implied multiplication there. Inside the parentheses, 1 plus 0.09 divided by 1. And then use your caret key to make an exponent, raised to the 1 times 5 power. And that gives us 2461. And we're rounding to the nearest cent so that the cents would be 0.80. 2461.80 rounded to the nearest cent, 2 digits after the decimal point. All right, if we compound quarterly, we're going to do a very similar calculation, but that's 4 times a year. So always write down what you are putting in your calculator. This will give me the opportunity to grade your work. I don't want an answer only. I want to always see where the answer came from. So you can let your calculator do the computations, but I need to know what the computation is. All right, so here I'm going to bring up my calculator, and thankfully we don't have to enter all of this in again. We can simply cursor up and then press enter and then edit that calculation. So I'm going to take out those 2 places where 1 was in the calculation, and I'm going to replace that with a 4 and then press enter. And if we compound 4 times per year, that gives us $2,496.81. So you can see where there's a benefit to compounding more than once a year. The more often you compound, the more interest you get on the interest. So in other words, they're putting money into the account. This would be if we were saving. This is a borrowing problem, but if we were saving, we're putting money into the account, or interest is being credited every quarter, and then interest accrues on that interest for the next quarter. All right, let's change that to monthly. Monthly would be n equals 12 times per year. We'll do the exact same calculation. A equals 1600 times 1 plus the rate, the annual interest rate, divided by 12 raised to the 12 times 5. So we're just changing that n value to 12. Bring my calculator up again and cursor up, press enter, and let's change those 4s to 12s. And that gives us $2,505.09. And then lastly, let's look at compounded daily. There we would have n is equal to 365 days per year. So A equals 1600 times 1 plus 0.09 divided by 12 raised to the 365 times 5. And you know what? I forgot to change that 12 to a 365. Sorry about that. We have 2 365s in the calculation. And now let's just enter that in and see what that computation gives us. And whoops, I'm going to edit the calculation that we had before, changing those 12s to 365s. And that gives us $2,509.16, or $2,509.16. If you notice, the amount that's in the bank after 5 years is kind of creeping up, but it's increasing more slowly as we go. And that's because if we compound daily, that's reaching a limit, and the limit is called continuous compounding. That's something we're going to investigate a little bit later in the unit. One more word problem here. As a result of the Chernobyl nuclear accident, radioactive debris was carried through the atmosphere. An immediate concern was the impact that the debris had on the milk supply. The mathematical model given here is y is equal to 100 times 2.7 raised to the negative 0.1 times t power, and that's used to predict the percent y of radioactive milk in raw milk after t days. So we are predicting the expected percent of radioactive material in the milk after 30 days. So that means we want to know what y equals when t is equal to 30. So y is equal to 100 times 2.7 to the negative 0.1 times 30. And we'll just enter that calculation in. 100 times 2.7. Use your caret key for making an exponent, raised to the negative 0.1 times 30, and do that calculation. That's going to give us about 5.08%. And we didn't have rounding directions on this one. Rounding directions will be very specific on your homework, and that is it for the lesson.